Welcome to ilectureonline. In this video, we're going to come up with an equation that determines the current through an inductor. And to do that, we're going to start with the equation that relates the voltage across an inductor with the rate of change of the current through the inductor. Now, remember that the current going through the inductor typically is a function of time. It usually changes with time, and that is caused by the voltage across the inductor changing with time as well. Or sometimes the voltage with respect to the source, or the voltage of the source, changes with respect to time, causing the current in the source to change with respect to time. So how do we find the current through the inductor? Well, we're going to take this equation and solve it for di. When we do that, we get the following. We get di is equal to 1 over the inductance times the voltage times dt. And then if we want to find the current through an inductor, remember that the current through inductor will change as the voltage across the inductor changes. So now we're relating the current to the voltage. We can say that I is simply the integral of di, which means that is equal to 1 over the inductance times the integral of v dt. Now, let's say that we start from time equals 0 to the final time where we want to find the inductance. Okay? But at some point, we may say, well, we don't want to start from 0 time. We may want to start from some initial time that may be different than 0. And at that initial time, there's already some current in the circuit. We can say that at time equal to time sub naught, we can say that I was equal to I when time equals t sub naught, which we can write as I of t sub naught. There was already some initial current. We want to take that into account, which means that the current then, as a function of time, can be written as 1 over L times the integral from t initial, whatever that t initial is, to t final of v, which is a function of time, times dt, plus the current that was already there at time equal to time sub naught. And so this, I need to include that here. This here is then the equation that allows us to find the current in the inductor if we know the equation that represents the voltage across the inductor, and if we know what the initial current was through the inductor at time equal time sub naught. And that's the equation we need to find the current.